Hi, Andrew. This is David. On this question here, I just have to get the coordinates of the lower point. The lower points, let's see here, the lower left corner, those 4 points have these coordinates here: 3, 1, 4, 1, 3, 2, 4, 2. And then the upper set of points are 8, 8, 8, 9, 9, 8, and 9, 9. Okay? So first, let's find the correlation coefficient for these four. Stat, regression, simple linear. X variable is var1, the Y variable is var2. And let's go ahead and hit compute. Move this up here and compute. And the correlation, as you can see, is 0, which would be what I would expect to see based on the way that the data points are organized. Okay? And do the 4 points in the upper right corner have the same correlation? Well, they absolutely should. Okay, if we don't believe that, let's run it again. Regression, simple linear, var4, var5, and compute. And as you can see, it is the same. Okay, and the answer is yes. And the reason why is because the upper points form the same pattern as the lower points. So that's the reason why. Remember that correlation is about dispersion. Dispersion is about pattern. Okay, and if I have a balanced pattern about a best fit line, then the correlation is going to be, there is no linear relationship there. Find the value of the linear correlation coefficient using all 8 points. So now what I need to do is come over here, and I'm going to add the other points right here. Whoops, excuse me, 9 and 9. And now I'm going to recalculate this again, but with all 8 points. So go to stat, regression, simple linear, var1, var2, and then hit compute. And here's the correlation. Okay, now as you can see here, I got a much different result. 0.971. 0.971. Okay? Using alpha 0.05, what does R suggest about the relationship between X and Y? Well, I can already tell you right now, I don't need to actually calculate a critical here. Okay, the test R, 971, is so large, okay, that there is sufficient evidence to support the claim of a linear correlation because the correlation coefficient is greater than the critical value. So it's the same sort of relationship. If the test correlation, which is this value here, exceeds the critical correlation, then I reject the null. If I reject the null, there is sufficient evidence. Okay? So therefore, B is going to be the appropriate response. Based on the preceding results, what can be concluded? Should the data from women and the data from men be considered together, or do they appear to represent two different distinct populations that should be analyzed separately? Okay? Well, you can see here that if I run females and I got a 0 correlation. If I ran males, I got a 0 correlation. If I ran both males and females together, I got a different result. Okay, so based on, without reading the problem thoroughly, okay, I'm going to say, to get a more representative approach of what exactly is going on here, I would say that the two different populations should be considered together. So let's see what happens. Nope, they didn't like that one. Let's see, the two data sets are from the same population. Two different data sets are from different, let's try A. The answer is B. Two different populations and should be considered separately. Okay. Well, again, if I read through this problem, I'm sure I probably would have come up, if I read through A, B, and C, I probably would have come up with that result. Okay? Thank you.